All right, we're going to do arithmetic sequences. I'll do it with my marker. Okay, an arithmetic sequence is like what we did for the warm-up. It's a pattern of numbers. Our job is to find first the next couple of numbers in the sequence, and then once we learn the explicit formula, we will be able to find any term in the sequence for any position. Before we can do that, you got to understand what this term D, common difference, means. So, Erwin, you spoke about the warm-up. How did we get from one number to the next number in the warm-up?
We subtract by 7.
Yeah, each time, right? So this is called your common difference. The common difference is how much it changes from one number to the next. So what this means, it says D equals, this is A sub n, sub, S-U-B, A sub n. Subscript is not like an exponent. We don't, so A sub 2 does not mean A squared. It means the second term. So the subscript tells us what position it is in the sequence. So what would A sub 1 be? The first term. A sub 2 would be the second term. What is A sub n? Well, that means any term. N is the nth term. It's some unknown term. This could be, so A sub n minus A sub n minus 1. This means some term in the sequence minus the previous term. So if this was the second A sub 2, what would this be?
A sub 3. A sub 1.
A sub 1. All right. So this means the second term minus the first term, or the third term minus the second term, or the 10th term minus the 9th term. Any term in the sequence minus its previous term will find our common difference. All right. So what is the common difference here? So this is negative 21 minus negative 42, which equals 21. So this is our common difference. Well, that makes sense, right? Because what's happening in my sequence? What am I going up by? 21. And what am I going up here by? So that's my pattern. So the common difference is just a pattern. So to find the common difference, you subtract any term from its next term. So subtract the first term from the second term, or the fifth term from the sixth term. Right? So what would be the next term here?
21.
So what is 21 minus 0? 21. What is negative 21 minus negative 42? 21. What's 0 minus negative 21? 21. All of them will give me the same common difference. And this is a linear pattern, which means that it's going to continue this way forever. Okay, we need this. So we know that D is 21. D is for difference, common difference. It means the same subtraction each time. All right. Once we have D, we're going to use this first formula called the recursive formula. We use this formula to find the next term, any next term. All right. So if we're at the 15th term, we would use this formula to find the 16th term. And it's very limited in scope. That's all we can use it for, to find the very next term. All right. This is actually not the one we're going to use most often. We're going to use this one more often than not. But I want to show you this one, and then we'll get to this one. So here's how we set it up. I'm going to erase this. Is that all right? So we have the common difference. I don't need this anymore. So we're going to set up the recursive formula. A sub n equals A sub n minus 1 plus D. So what term am I looking for? What would be the next term? What position in the sequence is it? So what is this term? This is the first term. What is this one? So what am I looking for? Okay, so this is how you do this. You substitute 4 in for n. We're saying a sub 4, which means we're looking for the fourth term. A sub 4 equals a sub 4 minus 1 plus, we already know the difference is 21. So what is a sub 4 minus 1?
3, a sub 3.
And what do we know is the third term? 0. So we plug 0 in for that. So a sub 4 is equal to 0 plus 21, which equals 21. So the fourth term in the sequence is 21. So what is a sub 1?
The first term.
What is it?
Negative 42.
What is a sub 2? What is a sub 3? What is a sub 4? All right, now we need to find a sub 5. So what would I do? Well, I would change this 4 to a 5. This 4 would change to a 5. So this would become what is 5 minus 1? 4. So all these would change to 5s. This n would change to 5 instead of 4. This would be a 4 because 5 minus 1 is 4. And what is a sub 4? 21. Did you see how we're using the previous term to find the next term? So what's 21 plus 21? 42. So what is a sub 5? 42. All right, now I want the next 3 terms, so what else do I need to find? So I already knew this stuff here. These were given. This is what I'm trying to find. So I found 2 of them. So what do I do to find a sub 6? Well, yes, you could just add 21, but we're trying to use the formula. So what do I do with the formula?
Replace 5 with 6.
Replace this 5 with a 6. Okay, let's do that. 6, 6, 6.
Sorry.
I don't forgive you. All right, so this becomes what? What goes here? 6. N, right? N is 6. And 6 minus 1 is 5. And what is a sub 5?
42.
42 plus 21 is
63.
63. So what is the 6th term? Okay. Now, what's the problem with this recursive formula? You can only find the next term. And really, we don't even need to use this formula to find the next term. We can just keep adding the common difference, right? So if we find the common difference, this formula is really unnecessary. It's very tedious, and it's very drawn out, and in my opinion, it's very unnecessary. Right? This formula, however, is very convenient. So I'm going to show you this formula. Yeah, Kenny?
Is this going to be on the PSAT?
Yes.
Since the PSAT is multiple choice, can't we just use mental math?
You could. But what happens if I ask you to find the 250th term?
I know, multiply 21 times 250.
And that's basically what this formula is about. But if you do that, what you're talking about, Kenny, you're forgetting about the first term and where it starts. So if you multiply 250 times, let me show you, okay? Let me show you. And I'll show you why your way, it's mostly what this is going to do, but it's a little bit of a tweak. All right, so let's find, instead of the third term, you guys got this?
Yes.
By the way, those were our answers. It was 21, 42, and 63. Let's find the 22nd term. Yeah, you could just do mental math and go up 22 times, right? But what is limited on PSAT? Time. We don't want to spend a lot of time adding 21 over and over and over again. And then what happens if you kind of lose track and then you're not sure, right? This way will tell you what it is and it'll be quick and efficient. So let's use this sequence here, 4, 1, negative 2. Okay, what is my pattern? What is my common difference? Negative 3. What does that mean? It's going down 3 each time, right?
Yeah.
So my difference is negative 3. I did that without using this, right? Just because you did that in your head, which is fine. You don't have to write this out. I just wrote this out so you have it. I expect you to use your reasoning skills to find the common difference. Yeah? Yeah, I'm sorry, this is example 2. Okay. So we're finding the 22nd term of this sequence. All right. And the first thing you're going to do with the formula is write the formula down how it's supposed to be written. So this is the explicit formula. It finds any term in a sequence. So write down the formula. A sub n equals the common difference times n minus 1 plus a sub 1. All right. Now this little letter here is telling us what term we're trying to find. So what term am I trying to find? I'm going to put 22 in for n. So n is the nth term. So you say a sub 22 equals, what is my common difference?
Negative 3.
Times 22 minus 1 plus, what is a sub 1? 4. Now I have an equation I can solve. So what's 22 minus 1 is? 21 times negative 3 is? Negative 63. Negative 63 plus 4 is?
Negative 59.
That's my answer. What does this mean? This means the 22nd term is negative 59. Now, isn't that easier than going 4, 1, negative 2, negative 5, negative 8, negative, and then you run out of fingers, and then you start got to put tally marks on paper, right? This is easier? Yes. So Kenny, you said, why don't I just multiply negative 3 times times 20, or 22, right? What's negative 3 times 22? What's negative 3 times 22?
Negative 3 times 22 is negative 66.
So does that give me my answer?
No.
No. But it's close.
So what if you did 21 times negative 3? And then
21 times negative 3 is?
63. And then you just add the 4.
Well, isn't that what the formula is?
Yes.
Yeah. So, yes, that's exactly what you're doing. But, you know, I'm showing you the formula to do that is exactly what you're doing in your head. The beauty about the formula is, if you know this formula, you can do this with any number. So what if I wanted to find the 250th term? What would I do?
Multiply.
No. Stop it. Well, I'm showing you. So, what if I wanted to find the 250th term? What would I do? Well, there's my formula. What am I plugging in 250 into where? In for n. So this is a sub 250 equals, the common difference is still negative 3 times 250 minus 1 plus 4. So you guys have the calculators. What's 250 minus 1 times negative 3 plus 4?
Negative 700. Negative 740.
Negative 743. That's a little easier than just drawing out a long table and subtracting 3 250 times, right?
Yeah.
Alright. So now let's read this and let's compare it to what we did yesterday. Yesterday we did this. We did f of x equals something, right? Well, now we're doing a of n equals something. So think of this n as the x in our function notation. So when I plugged in 250, aren't I just evaluating the function for 250? Yes. So it's very similar to function notation. But it's not, we don't write it the same way. It's not it's not a of n, it's a sub n, but it's the same thing as a of n. Got it?